Hi there, my name is Conor and I'm a Customer Success Manager at Silico. In today's video, I'm going to demonstrate how the Silico platform can be used to create a digital twin of a hospital. The purpose is to demonstrate how digital twin technology can help managers of hospitals as well as budget allocators in organisations such as the NHS to make decisions around things like allocation of staff between hospital departments as well as allocation of budget to certain hospitals or regions. This demonstrates how digital twin technology can help large organisations such as the NHS to provide their services in the most effective way possible, even when faced with considerable budget constraints. The model we're going to show today is a highly simplified digital twin of a hospital. We're going to start off by demonstrating how the dashboard of the twin could be used by hospital or NHS managers to test out decisions such as target wait times or staffing policies, and then see their impacts on, for example, actual wait times, actual projected wait times, and actual hospital finances. We'll then move on to show the actual digital twin underlying this dashboard to explain how such models could be built. So let's start off with the dashboard. Okay, so here we see the dashboard for the hospital twin. So this particular dashboard has been designed for decision makers who have control over 3 different variables. So in this case, it's going to be the target surgery wait time, the target ED wait time, and then the actual number of nurses available. So those are the 3 inputs that we see here on the left. And essentially, decision makers can play around with those different variables to test out their impacts, changes to those variables, and how they will impact the actual surgery wait time, so actual as opposed to the target, the actual ED wait time, and then also the required nurses. So how many nurses would be needed in order to actually achieve that wait time, so that the actual wait time equals the target wait time. And then we can also see the impact on things like waiting lists, so the number of patients on the surgery waiting list and the number of patients waiting in the emergency department. And then finally, we can connect all of that to have a look at the financial impacts of different decisions. So looking at the salary expenses, where we can look at different hourly wages potentially as well here if we want, as well as revenues. So if there's a funding model where the hospital is paid back from an organisation like the NHS on a per patient treated basis, and then finally the profit of the hospital over time as well. Okay, so now that we've given an overview of the dashboard, let's use it to test out a certain decision. So let's say that we want to test out the decision of reducing the target ED wait time from 4 hours down to, let's say, 30 minutes. So what we can do is, we've already named a scenario here of lower ED wait time, and we can then drag this down from 4 all the way to 0.5. So it's now half an hour wait time. And we can see this orange scenario is represented by this lower ED wait time basically. So we can see here the impacts of that. So that change is now obviously reduced our actual ED wait time quite significantly. So it's down to 2 hours. So we've shaved off 13 hours for the actual wait time. We're still not down to the desired level because we don't have sufficient nurses to achieve that. But what we can also see is that we've actually somewhat increased the surgery wait time. So the additional 13 days here. And the reason for that is that the model underlying this allocates staff based on the target wait times. So the target wait times are set higher. That means that staff, there'll be more nurses allocated to ED, and that comes at the expense of the nurses that are allocated to the surgery department. So essentially, setting different target wait times is a way of allocating nurses between those staff and setting the relative importance of each different department. And what we can also see then is that that's obviously, by having a more ambitious target for our ED, we have increased the number of required nurses that would be required to achieve that. So we can see that we would need an additional 8 nurses if we were going to completely achieve our target. And we can also see that we would obviously reduce the patients waiting in ED because we're treating them faster. But we would also increase the waiting list for surgery at the same time. And now finally we can look at what would be the financial impact of this. So our expenses are the exact same because we haven't increased or decreased our nurses. We've just allocated them differently between different departments. We have a slight decrease overall in our revenues because there's different revenues for surgery and for ED. And with the reduction in surgery, that's kind of slightly reduced our revenues. And then we can see the actual impact on our profit as well. So we've slightly reduced our profit in this case. Without obviously any change to expenses, just based on the change in revenue as well. Okay, so let's test out one other decision in the model. So let's imagine that we are maybe trying to figure out how much budget would we need if we were to hire as many nurses as are actually required in order to achieve the target ED and surgery wait times. So we've created a scenario here, which you can see on the left in the actual model, where the actual total number of nurses available is going to equal the required. So we can see that this purple line here, which represents this scenario, in this scenario, the actual nurses available is going to be the same as the required nurses. So obviously that allows us to achieve our target surgery wait time of 50 days and our target ED wait time of 4 hours. As we can interestingly see here, the total number of required nurses in the base case is actually higher at the end of the simulation period. And the reason for that is that if we're not hiring kind of in proportion to the needs, by the end of the simulation period, the backlogs will have increased significantly, right? So we don't have enough nurses to treat the patients coming through. Therefore, the backlogs and the waiting lists are increasing further. And therefore, to get those waiting lists down to the level required to actually, meet the ED and surgery wait times, target times, we'll need to hire a lot more nurses at that stage. So this kind of shows you how underinvesting now will lead to, consequences later down the road. And through simulations like these, we can get a very clear understanding of what those consequences would be. So we can see here that in the future we'll need to hire more nurses in order to get closer to our target wait times. So we can also see the impact on waiting lists. Obviously with more nurses hired now, it starts to reduce our waiting lists relative to the base case for both ED and surgery. And then finally, if we look at salary, so up until this point the required and the actual was actually was the same, but from this point on we started hiring more nurses to deal with the fact that we didn't have sufficient capacity. So we started to hire more nurses and therefore our salary increased. We can also see our revenues here increase because we're treating patients faster, and therefore there's more patients treated over the period of the simulation. So we've increased our revenues by about 1.1 million. However, our costs have increased by about 2.43 million, and therefore our accumulated profit is about 1.3 million lower than it would be in the base case. So we can essentially see what would the cost of this policy be, of actually hiring to meet the actual target wait times, and then we can obviously use that to make a decision around whether or not this is a viable option or whether there is insufficient funding and we therefore need to just focus on allocating staff in whatever is the most effective way possible. Okay, so now that we've shown how the dashboard of these models can be used to test out certain decisions and get insight into what the implications of those decisions would be, we can now turn to actually looking at the underlying digital twin that actually produces these results. So to do that, we can click on the model builder page on the left here, and we're just going to look at this for now in the base case. So this is obviously a highly simplified digital twin of a hospital. A real digital twin that would be used for actual decision making would need to be have additional complexity to capture more detail about how patients and staff flow through a hospital. But just to demonstrate the concept, we've created this quite simplified version of a digital twin of a hospital. So what we have is basically a model that runs in days. So we're starting January 1st at midnight, and we're running, sorry, not in days, we're actually running in hours to capture the change in patient ED demand. It generally kind of fluctuates quite a lot per hour. As you can see here, what Silico software simulation software is able to do is calculate a new number for each hour within that simulation period. So if we look, for example, here, we can see there's a different number captured for every hour between the start and the end of the simulation period. So essentially we have patients turning up at the emergency department. Those patients then need to be treated, and there's a certain wait time in order to do that, and we'll click into that in a moment. But once those patients are treated, that then triggers the financial aspects of the hospital, which is also affected by the staffing levels. And what we can do is basically just click into here to see how do we determine the actual nurses allocated to the department, and how does that then determine the patients that get treated on an hourly basis. So we can see here that the target wait time is 4 hours for the ED department, and what we're saying is that basically if there is, in this case, 1100 at the end of the simulation period, there's 1100 patients waiting in the ED department. That means you would need to treat patients, you need to treat 275 patients per hour if you were to achieve that target wait time. And if nurses can do 6 patients per hour, if they can treat 6 patients per hour, that means you would need 45 nurses in order to meet that target wait time. However, as we've seen here, we only in this model we've only got 30 nurses available, and so we're at a staffing adequacy by the end of the simulation period of about 25%. And so if we click in here, we can see that the actual nurses allocated to working in the emergency department is only 11. And if we multiply that by the patients that they can treat per hour, we see that the maximum processing rate is only 68. So the 73 turning up, let's say, in this hour, we can only treat 68 of those, and therefore the remainder between the two is getting added to, accumulating further the stock of patients that are waiting in the emergency department. And then we can also estimate the waiting time. So this is the projected waiting time, by saying that if there's 1,100 patients waiting in the emergency department and you can treat 68 in an hour, if you divide one by the other, that gives you an idea that you could, within 16 hours, see any more patients that turn up at that given hour, and they should be seen within about 16 hours from that point in time. So that's one way to kind of calculate all of that, and we can then obviously look at the finances of the hospital, and based on how many patients are getting treated and the revenue that you get per treatment type and how long that takes, you can determine the revenues, and you can also then determine, based on how many nurses you have working and what their hourly wage is, what the salary costs will be, and then that will obviously help you to determine the accumulated profit and or cash flow of the hospital itself. So obviously when you add in additional detail about other expenses and other sources of revenue, we can start to model out the actual cash flow within the hospital and budgeting requirements for that, etc. So that concludes the video for today. I hope you've learned a bit about how digital twins of a hospital can be used by decision makers either within hospitals, within the NHS, or any other areas within public healthcare, or even more generally within allocation of resources for large organizations. And also hope you've gained an understanding of the underlying methodology and how these models are built, and how the Silico software can be used as a platform for building these kind of digital twins. So it would be great to hear your comments. Feel free to comment or leave questions in the comment section below, and we look forward to introducing more content like this in the future as well. Thanks a lot for your time, and take care.